Cool. So I'm going to make up some time probably. I'm going to read this so I don't make any mistakes and Sue doesn't have to get a hook and take me off the stage. So, by 2002, the city was aware of potential impacts to our water supply system from changes predicted by climate science. We began attending climate conferences and year by year listened to climate modelers become more confident predicting regional changes to temperature and precipitation patterns. The city's interest at the time was due to our water supply system, including diversion of Middle Fork water to augment our main source in Lake Whatcom. We learned that North Cascade glaciers, including the Deming Glacier at the headwaters of the Middle Fork, were receding due to small changes in seasonal temperatures. This picture shows the recession of the Deming Glacier from 1984 to 2011. The demarcations are in different colors, and the top one is in 2011. And you'll notice that the retreat isn't just upstream, if you will, but it also is, the glacier is also melting on the sides, so there's significantly less glacier in total. Yes, and so this one here looking, did I just have those wrong? Okay, this one shows the screen has two pictures on it, and I was just watching the one I wanted to. So this picture shows a little bit clearer how the glacier is also coming down slope from the sides as well as retreating up towards the mountain. And when we have changes in precipitation and the melting of the glaciers, we get events like this. And those events turn into events like this, which we've all seen. This one is in the area of Ferndale looking up valley. The river stream itself is barely discernible. Another consequence of increased temperatures is change to the type of precipitation. When mountain precipitation changes from snow dominant to rain dominant, or when increased temperatures melt the snowpack sooner in the spring, we get those flood events like that, and similar events throughout the county. In 2005, the city conducted modeling of impacts to the Deming Glacier and flows in the Middle Fork that would result from a 2 degrees centigrade increase in ambient air temperature, an increase that was conservative in light of what the climate models were predicting. The glacier with that condition of a 2 degrees centigrade increase in ambient temperature would no longer significantly contribute to flows in the Middle Fork. This graph here is from a 2005 study that we did, and I'll explain the graph a bit. The blue line is a simulated natural stream flow over the period of record, the 1944 to 2003. So that was an average stream flow simulated for that period of record. The pink is the simulated natural flow over that same period of record with no glacier as a result of that 2 degree centigrade increase. So this is for March, and you can see that there would have been more water in the river if we wouldn't have had the glacial contribution, because we would have had more rain with the temperature increase, and we would have had more rain than snow. The red bar is simply the in-stream flow requirement for that month, and it's just there as a reference point. This was a slide that's been repurposed from another study that we did. So compare this with the pink or the purple or whatever it is bar on top to this, which is July, and it's constructed the same way. This is the stream flows simulated for the period of record, and this is for the month of July. And you can tell that the stream flows drop significantly by the end of July from March. Here they're above the natural stream flows, and here they're below the natural stream flow. The y-axis is CFS, and the x-axis is something I'm not going to explain much. It's exceedance flows, and it simply means the percentage that the stream has more water in it than other times. One thing I'd like to point out is that in wet years, the Middle Fork contributes something up to 30% of the flows are contributed by the Deming Glacier, and in dry years it's 30%. In wet years it's up to 20%. So it's a significant amount of the flow in the Middle Fork is contributed by the Deming Glacier and by glaciers generally. I think that's good for that. Like I said, I was going to read this. Since 2005, the city has considered the responses to this information that we received from our modeling and from the regional climate models. In 2009, we drafted an adaptation analysis which evaluated vulnerabilities to climate change and what the city could do to adapt to what appears to be unavoidable climate change. Water supply, energy use, and sea level rise were determined to be our greatest vulnerabilities. Since then, since 2009, we have initiated further studies and experimented with changes to management of our water supply system. And we are continuing to explore management protocols that will reduce our vulnerability to temperature increases and to the unavailability of glacial water in the Middle Fork. Another consequence of rising temperature is increased biological activity in Lake Whatcom and other regional lakes. We have experienced more intense algae blooms that have challenged our water treatment capabilities. We are now adding a component to our water treatment system that will lessen the impact of algae on our treated water capacity. This biological activity also increases phosphorus cycling in the lake, and if you're tuned in to what the cities and the county is doing to remediate phosphorus loading into the lake, you'll know how important this is to us. And it adds to the challenge we face to reduce phosphorus loading and impacts on the lake. In conclusion, the city, did I do that again? Yes. In conclusion, the city has recognized the potential of climate change impacts for quite a few years and has taken cautionary steps to adapt to the impacts. And this last slide shows the two reservoirs that the city relies on, Lake Whatcom and the one that we all rely on, which is the snow up in the mountains. Thank you.
Thank you, Claire. That actually gets us a little closer to being on time. So our next speaker is, we're going to ask Doug Allen to come back, and he's going to talk a little bit about some of the international border issues that we need to consider in water supply planning.
So I have many fewer less slides this time than last time. So that means I get to talk really, really slow. I'm with you. All right, here we go. Whoops. So I was asked to describe cross-boundary efforts to address water management and its effect on Whatcom County residents and water users. And this is a photograph of Bertrand Creek near the border with Canada, and it's a really nice reach of stream, and it is spawning habitat for steelhead. There are other areas, reaches of several other streams in that part of the county that also have steelhead, and this reach, like many others, often runs dry in August and September. A lot of times it's low flow, very low flow, single digits. But there are times when it runs completely dry. Not very good for fish. So the watershed's primarily affected by low flows from BC, affected by water use in BC, British Columbia. This is Bertrand, so to hold this steady, I'm supposed to do like that, right? And there's Fish Trap. So this is the border. So about half or 2/3 of those two watersheds is in British Columbia. So again, flow in Bertrand Creek, often less than 20 CFS in July through September. Same for Jackman Ditch, one of the main tributaries to Bertrand Creek. And Fish Trap Creek is also subject to low flows in the summer, but it does get some augmented by groundwater from the Abbotsford-Sumas Aquifer. So it doesn't get as low as often. Pepin Creek, a tributary to Fish Trap, can be dry in the summer. And then turnabout's fair play. Sometimes we don't send very much of the Sumas River into Canada. So a simple question: Are we depleting the aquifer serving most of northern Whatcom County and a lot of the Abbotsford-Sumas aquifer? And I wanted this to be a really simple answer that no, we're not. But the more I think about it, it's not a simple answer. It is not mined in the sense that it doesn't get lower every year, like some aquifers in the state. In the Odessa sub-area, that one is diminishing by 10, 20 feet every year. It has been for many years. In Abbotsford-Sumas aquifer and many of these other aquifers in this area, they are fully recharged every year by rain. These are not snowpack or glacier-driven aquifers. The Abbotsford-Sumas aquifer is not really. There could be some effect, but generally it's rain-driven. And we get plenty of rain every winter, and it fully recharges. But in the summer, we do withdraw water, and we do lower the water table in a lot of these areas from our withdrawals for irrigation and other uses. And in some streams, that means the recharge and gaining reaches may be diminished. So we do affect it, but it's seasonal and it's recharged every year. Another interesting thing is the aquifer generally flows from northeast to southwest, and it depends on what map you look at. But this one, it shows that the aquifer starts about here. You could say it probably comes up here at least. But the interesting thing is the aquifer is still flowing southwest, whereas the river flows from south to north. So there are also two what may be considered endangered or at least threatened fish species in both the Nooksack and the Fish Trap watersheds: the Salish sucker and the Nooksack dace. So low flows is impacting them. Their numbers are low. It's a concern, but we really, between us and Canada, not a lot is being done to improve that. And then another big challenge for us is high nitrates in groundwater, and that affects at least 10 small water systems in the upper watershed, and possibly numerous other individual wells that we don't even know about. This is a sampling of wells done in the 1990s that shows the red dots are high nitrates, and we have been working a lot with some of these folks where we have some of these water systems that have high nitrates, and then another cluster over here. This group, we've been able to get alternative sources of water. Some of that is clean groundwater from the Sumas area. We're still struggling with this part. And then in some of these other hot spots, we don't know exactly what's happened there. A recent study done by our environmental assessment program found that one sampling of wells, 26 wells, actually was showing some improvement in most of the wells, and that's good. And, even though there was improvement, a lot of those wells were still over 10 milligrams per liter. Oops. And then, and we've had some work done. We've had Abbotsford-Sumas aquifer Transboundary Task Group has worked on that over the years, like it goes clear back to the 1990s, and the last time we worked on it was 2012. And then we are now working, we have a transboundary work group working on fecal coliform. And so when we, with the Washington Shellfish Initiative, we started doing a lot of work on trying to reduce the amount of fecal coliform getting into the tributaries and down into the Nooksack River in Portage Bay for shellfish beds. And, we were finding that a lot of times water was already high in fecal coliform coming across the border. In a lot of cases it got worse as it went down, but still it's pretty tough to make a lot of progress when it's already, it's already really high. So we started trying to work with British Columbia, the Ministry of Environment, Ministry of Agriculture, and put together a very simple model. It's our charter. It's a lot more complicated than it really is, but we've worked together now for a little over a year, and we hope to provide recommendations to what they call the Environmental Coordination Council, which is essentially Department of Ecology, Ministry of Environment, and then the other agencies that feed into that or can affect that, as well as EPA and Environment Canada. And so by January, we hope to have a list of recommendations to send to Maya Bellin, her counterpart with the BC Ministry of Environment. And the point being, we haven't done a heck of a lot in water resources with cross-boundary, transboundary cooperation. We've raised issue at times when there's a dam on the border, and so no water can come across, and we've contacted people and said, hey, can you help us out? But nothing really formal, nothing really very organized, and if somebody's got some examples that prove otherwise, I'm happy to hear about that, but I haven't been involved in much. But we do have this model that started with work on nitrates and now is working on fecal coliform, that at least we've got our foot in the door. We have a history now of cooperation, and I think there could be some promise there some way. And that's about it. That's really all I've got. Thanks.
We're holding off for questions till we get our final panelist today's presentation done. And we're pleased to have Mark Personius here. He is the Assistant Director of Whatcom County Planning and Development Services. And we gave him the really, really easy talk about how to reconcile land use and water demand. We wanted to give him 40 minutes for this. We were able to talk him into 15. So in any case, help me welcome Mark.
Hello. Sorry for the delay. Good afternoon. I, just to let you know, generally don't follow PowerPoint rules very well. So some of these slides might be a little busy or unreadable. All right. Oh, there we go. Okay. So I'm going to talk about these things. What does GMA require counties to do? Talk about a little bit about the plans and procedures that are already in place to address our water resource needs from a future growth standpoint, and how water law complicates that planning under the GMA, and then how we reconcile competing land use and water needs, and finally a little bit about what our challenges are going forward. So just a quick primer for you on the Growth Management Act planning requirements for counties. We have to prepare a comprehensive plan and implementing development regulations to accommodate 20 years of projected growth into the future. We have to do that every 8 years, and that takes about 3 years to do that, so we're pretty much always doing it. Generally, and I'll show you a map here in a second, if you were to fly over the county or the state that was planning under GMA and you had your GMA glasses on, there would be three colors, basically. There would be urban growth areas. Those are cities and towns, basically. There would be, secondly, what are called natural resource lands of long-term commercial significance. Those are ag lands, forest lands, and mineral lands. And then the third class of GMA lands are the rural lands, or basically everything else. So in general requirements, and I'm focusing this on counties, the idea is under the GMA you encourage more urban growth in the future and less rural growth over time. That we are required to protect agricultural lands for their long-term commercial or economic significance. We have to adopt critical area regulations to protect the functions and values of environmentally sensitive areas, including streams and aquifer recharge areas. And we'll talk a little bit about those impacts. And most significantly, especially in light of the Hearst case, we have to adopt measures, what are called measures to protect rural character. And those include a wide range of things. So we are supposed to provide for traditional rural lifestyles. We are supposed to provide for rural-based economies and opportunities to both live and work in rural areas at the same time as we are to protect surface and groundwater resources. And it's that last phrase that was really the foundation of the hearings board original decision that the county did not meet GMA requirements because we weren't adequately protecting surface and groundwater resources. So as a measure to protect rural character. So here's the map. This is our future land use map. So those colors, this dark green area in the eastern part of the county, these are the forest lands of long-term commercial significance. The lighter green areas are agricultural lands of long-term commercial significance. The tan areas are the rural areas, and then the purple and the yellow areas are the cities and the urban growth areas. So that's where most of the growth is supposed to go in the future. Just so you know, we don't tell people where to live. GMA does not do that. It's a free country still, and you can live anywhere you want as long as you can afford it and you can get water, of course. I'm going to talk about what our obligations are, responsibilities now are under GMA. Now, since the Supreme Court has said that it is now county's responsibilities to manage this water and development. We're going to talk about water for people. We have to plan for water for jobs, water for agriculture, and water for fish. So more than 2/3 of the existing county population lives in cities and urban growth areas. And we just went through an update to our comprehensive plan that was adopted in 2016, adopted last year. The 20-year growth forecast out to 2036 is for about 70,000 new people countywide. That's almost another Bellingham. And 37,000 or so new jobs to go with those folks. 85% of those people are expected to live, or were allocated, that growth was allocated to cities and urban growth areas, and about 15% was to live in the rural areas. That 15% of that allocation comes out to about 11,000 people who would be projected to live in the rural areas. Now, those folks may be dependent upon permit-exempt wells, or they would have been at that time. There are public systems, as you've heard about, and Sue talked about, and Dave Olson will talk about a little bit later this afternoon. But those are the folks that are most directly affected by the Hearst decision and those permit-exempt wells. We do have, though, procedures, as Sue mentioned this morning, for the provision of public and private water supplies laid out in the Coordinated Water System Plan that was also adopted in 2016. So let's talk a little bit about agriculture. Two studies have already documented, I think Gary mentioned that this morning, about the agricultural water use by sub-basin. So we have a pretty good understanding of where that water is being used and for what purposes, for the watering of what crops and so forth. In general, overall, there's actually more land authorized for irrigation on existing water rights certificates than is currently irrigated. However, in some sub-basins, that actual water use exceeds that's authorized. So you have more paper water than you actually are having actually used countywide for agriculture, but in certain basins, it's the other way around. Sue talked about this morning the projections about agricultural irrigation use has been increasing in the last couple of decades here in the county. A lot of that has to do with the dairy or the dairy to berry conversions. We expect, at least conventionally at this point, though, that that's probably going to kind of become more stable in the future. That we think we've probably, based on water use efficiency and irrigation efficiencies and drip irrigation, and perhaps even from climate change and less water availability, or the conversion of some of those hay fields to berries, less water would be used, and so we expect that to kind of plateau in the future. But that last bullet is really the big challenge to us, is if we're supposed to protect agricultural lands of long-term commercial significance under the GMA, well, we do that conventionally now by designating them at very low density, 1 unit per 40 acres, and allowing agricultural uses as much as we can, or making them as expedient as we can, and not allowing uses that would hopefully or potentially conflict with agricultural use over the long term. But how do you ensure beyond that, how do you ensure that those lands have access to an adequate water supply, which now, after Hearst, adequate means not only factually or physically available water, but it's actually legally available. That is, not that I'm giving anybody any ideas about how you should sue the county for not complying with GMA, but Eric, you're not in the room anymore, are you? Oh yeah, there you go. Okay, and lastly, water for fish. And Treva spoke to this well this morning about the in-stream flows. I'm not going to go back over that, but those were set by the Nooksack rule. The challenges for us, again, under the GMA sort of umbrella is how do we protect those in-stream flows in the future from habitat degradation, potential changes in climate that Claire talked about. Why did you guys leave? Jeez. And the projected surface and groundwater withdrawals from both population growth and agricultural use. So all of those things have to kind of go into the factoring about this. Okay, just real quickly about in-stream flows and fish. This is a hydrograph of the Nooksack at Ferndale. The blue and the reds are just 2 different years, and in this hydrograph, you see the great deal of variability. Every year is different, of course. And the green line is the in-stream flow rule plotted from across the year. And so you'll see, even in the wintertime, the in-stream, or the actual flow can go below the in-stream flow, even in December and January. And of course, what happens, we expect it more often in the low flow season in the summertime as well, but it also happens throughout the year. This is an example, being the main stem. It's a snow-fed, mountain-fed stream, so you see this flash of spring snowmelt here getting a big rush in late spring. This is an example of Bertrand Creek. It's hydrograph. Same thing, except you'll see here, this is a lowland stream, so it's not snow-fed, so it has no spring push. And again, but the same thing. You see where those flows go below their in-stream flow, then that water is not legally available, and that's why those streams are close to any future surface water withdrawals. Okay, so the coordinated water system plan, as I talked about, identified existing uses and future demand for potable water for domestic use, right, for both municipal and domestic, urban and rural use. Oh, I'm running out of time. Excellent. It looked at who the water providers were, the public purveyors, the Group A's and Group B's, as well as the private permit exempt suppliers. And I think, as Sue talked about, well, there's the vast majority of folks are on a public system, which is good news in that those folks have secured water rights. But there are other issues, primarily economic ones, about the cost of providing water and the location and the access to that water. We also looked at identifying public water system future right capacities, those who had water rights, and those water systems that had water rights that could supply all their water at build-out, and those that couldn't. And I'll show you that slide in a second. So this is, again, a map. I think Sue showed this. These are all our public water systems. They do cover a good chunk of the rural area. But prior to Hearst, if you couldn't get timely and reasonable service from a public purveyor, then you could still drill a well. Well, now that's still the case, but now that requirement is that you have to prove that there's no impairment, or if there is impairment, you have to prove mitigation, or you have to provide adequate mitigation, which of course makes it either much more difficult or much more expensive to do for an individual. This map shows those water systems, the largest of the water systems that we have, in kind of a green, yellow, red format about their water right capabilities. So those with the darkest green and the light green have adequate paper water rights to handle build-out under the current zoning. Those with yellow would run out at some point before they got to build out, and then those with the red are those that are already exceeding their water rights and so couldn't really accommodate any more growth. Quickly, on the water law complications, the Postema case basically said that an in-stream flow cannot be impaired, and there is no really difference between a de minimis impact or a significant impact. So one drop of water is an impairment. Foster came along in 2015 and said that you can't do out of kind, it has to be water for water. So if you do impair, you have to replace that water at the same time, same place. And then the Hearst decision came along and said, not only does Postema and Foster apply to water right decisions by the Department of Ecology, but now they apply to county decisions, land use permit decisions. So we are required to deny a permit if there's impairment unless you can mitigate. So that's just kind of the triumvirate of cases that really brings us down on counties. So the challenges we have is to collate that existing hydraulic continuity issues that were talked about, the stream flow data, the water use and supply data, and the projected climate change impacts into a kind of a cogent water supply plan. We have a lot of information that's been out there, but as Gary's slide showed, it's kind of been on different tracks, and we need to bring all that data, bring all that information together into one clearinghouse. And coordinate those water resource management efforts under the different stakeholders. And lastly, the uncertainty or certainty or lack of certainty about the legal or statutory framework from which we go about this. Right now, we're operating under the Hearst decision best we can, but as some folks have talked about this morning, the legislature is likely to do something to address Hearst, and so that legal ground is probably going to change, and so that makes it hard to plan, especially on the long-term effort. Those mitigation options that have been talked about are either, you either do something on site and a property owner can mitigate on site, and you would design a system to do that, or is this a government responsibility that property owners shouldn't have to be responsible for mitigating this, but this is an issue where governments are responsible, and therefore this should be done on a basin-wide standpoint. Those are kind of the two different sort of constructs about how to think about that. State legislature looking at should this go back to ecology, and should we go back to looking at it basin-wide? And what has been proposed in some cases is kind of a mitigation fee in lieu program that you could actually, the county would give you a permit, you could develop on your well, you'd give us some money, And then that money would be used to come up with a mitigation or restoration plan for the basin, and the governments would be responsible for figuring out how to mitigate that consumptive use of water. Of course, as Gary mentioned this morning, that needs money to do that. Or should we look at refining GMA to reinforce ecology's really the best agency to do that, not 28 or 29 different counties doing it? Should there be a distinction between a de minimis and a significant impact, and really kind of on the legislative side? So that's where we're focused on. I'm going to talk very briefly here before I get the hook. I'm going to show you some maps about some of the work we're doing at the planning department and at the county, looking at the cumulative impact analysis. We need to focus on rural development, is what we're doing specifically right now, and doing a build-out analysis so that we can use that data to figure out by sub-basin how much water are we going to need for growth, and then in each sub-basin. So I'm going to give you a real brief idea. This is a quick vision test for those in the back of the room. This is a build-out analysis just we did. We looked at properties inside and outside of public water system service areas, classified those that were already existing. Those were in Group A systems, Group B systems. Those were outside of Group B systems, those properties that were already platted or fully undeveloped. And based on that, this is an example we've done we use the Deer Creek Water Association. We can go into every water system service area now and plot developed properties, underdeveloped properties, and undeveloped properties per existing zoning. We can do a build-out analysis. In this case, we actually had data from the water system that showed where their existing lines were, where the pipes were. We could do an analysis we did a build-out analysis for that entire water system, and then also show proximity to where those pipes and pumps are, so you get some idea about a little bit better idea about feasibility of future growth. Now we can toggle that data through GIS, the same data, but now here we look at the Deer Creek subbasin itself. So instead of the water system, we look at the subbasin, and we can do this countywide now. So I think this is a really good tool. It's going to help us kind of get to that cumulative impact build-out analysis, at least on the growth side. And finally, this is just a quick slide show you. Again, those yellow areas are the public water system service areas. The blues and greens are where parcels are served by permit exempt well, best we can ascertain from the Department of Ecology well database. And you'll see, even inside the public water system service areas, there are areas where that are still using permit exempt wells, because that's what the rules allowed at the time. And finally, this is going a little bit deeper about just getting to a build-out analysis based on what parcels are developed, vacant and undeveloped, kind of rolling up that data I showed you just a minute ago, kind of to a countywide basis, and that's what I'll leave it at that. Thank you.